All right, good morning. And announcements. Well, just go over some important items. Your lab number 1 will be due this Wednesday, 2 p.m. So since the policy goes like, if you submit your best effort, you get a full percentage. Take advantage of that. So submit something before Wednesday, 2 p.m. On the other hand, I'm actually going to release a detailed solution to walk you through how to develop the code. I think that'll be very important for you to get prepared for lab test the programming test 1, which will be next Tuesday, right? So we really should stick to the schedule as much as we can. But it doesn't really mean you should really only submit something that's not so good by the deadline. You should really submit the best you can so you can really get the best feedback from us, right? That's really to your best interest. Your written test number 1 will be tomorrow during the scheduled lab session. For the exact protocol and policy, please refer to the guide, PDF, which I already announced last week. And so important for you to make sure you can log into eClass and log into the lab computer. If you cannot, any delayed, you will have to be responsible for that tomorrow, right? You still have time to drop by the Williams Small Center and try.
For the first lab, just so you know, like if there's like any blue boxes, like is that fine? Like when we submit?
What do you mean blue boxes?
So like from like the J unit.
Right. Oh, you're saying that if you actually haven't passed all the test cases, you didn't get a green bar. Is that what you meant?
I mean, like if we pass like some of the test cases.
Yeah. Basically, you're saying you're not getting a green bar for lab 1. I would say as far as your lab bar is concerned, as long as you submit something, you get a full marks. That's a policy, right? On the other hand, you really want to try to get a green bar as much as you can, because otherwise you might have the same issue when you get to the actual programming test. All right? So you can submit your best effort. That's okay. Okay. All right. And for your programming test number 1, I will give you guys more information shortly after the class on Wednesday. But you can assume that you're gonna get a guide, some practice tests. You can definitely do it from home. On the other hand, I would suggest you also try maybe the lab environments to see how the lab test mode will feel like. That's something I will try to set up. Maybe not this Tuesday. We don't have enough time. Maybe we'll do that on Friday. I'll set up some time so you can just drop by the lab and try it yourself. It's optional. Yes?
How long are the written tests?
It's set in the guide, 30 minutes. Okay, just so that you know. Good. Yeah, because Tuesday, if you think about the time schedules, our written test will run until like 4:50. We got very limited time left for the lab session. So what I will do, I will look at the lab schedule on Williams Small Center on Friday. I'll try to see if I can reserve at least like a 2 hours block. So you guys can just drop by any time during the 2-hour block. Yeah, just give it a try. Yeah, it's optional. I can tell you that taking your programming test while in the lab would be very similar to how you use the Eclipse on your home machine. I think the only difference would be you had to log in using your EECS credential. And also you have to kind of download the starter from somewhere and then import it and export it for submission. That's the look and feel might be slightly different, but it should be very consistent. So don't stress over too much if you don't have a chance to try the mock-up test, all right? But if you can, why not? All right, let me start with the final topic, which I want to cover also properly for the OOP review. After this, we are done with the review. All right, let's start with this. Maybe you guys already started studying some static variables over the weekend, hopefully. So what I would suggest is, let's take a look at this fragment of code over here. I would suggest you guys actually take a look over here. Okay, I'll give you guys just 1 minute. Stare at this fragment of code over here, and then we'll talk about it. Hey guys, hi, please, thank you. And I can tell you there is one error in the code, not at the runtime, at the compile time. Meaning that if you type this out on Eclipse, you're gonna get some red underline. Now warning, error. You might find this very similar to what we said will be the solution for automatic management of the counter back on Wednesday, but not exactly the same. Well, slightly similar, but there's some point over there. You might be wondering what static here really means for method, which we didn't really explicitly talk about. You can think about the way you're going to call a static method will be very similar to how you call a static variable. You don't need a context objects, which of course I will show to you. But for now, just for your judgment, you should know everything. You should have everything you need. All right, so at least you kind of get an idea about what's really in the lines. Can anybody want to take a guess, like which line got an error? Line 6. Why would you think line number 6 would be an error? Let's take a look. Okay, let's take a look. Okay, the same fragment of code. You can see for line number 6, we're incrementing next account number, which is an integer. That's fine. We did something very similar to increment the global counter on Wednesday anyway, so that one's not a problem. Okay, line number 6 is fine. You don't have many choices, actually. Yes? 3? You said 3 over here? Why would you think that's a problem? Sorry, did I say that again? I didn't quite hear you. Oh, how nice. But that's a good catch, but that's not my intention. Very good. Thank you. You're absolutely right. Yeah, that's a good one. Of course, if that's a real test, I have to give you credits. But let's say that's not the one. Very good. Yes? Over here, static variable you meant. Over here. You're talking about over here, right? Yeah. Is it this one here or this one here? Which one? Are you talking about number 1 or number 2? Number 1? I can tell you number 1 is actually fine, because if you look at number 1, it's referring to branch name, which is declared to be non-static over here. You can definitely say this dot non-static. That's basically how you're supposed to use it. That one itself is okay. However, that part is also the error. I think you pointed out correctly that that part is actually the error. However, the explanation is not right. Not really. That one's okay. Actually, by the way, in Java, you can easily say, for example, if I say string s would be equal to, for example, let's say York plus maybe 50. That's actually absolutely fine in Java. It's going to promote the integer to be a string. So you're still going to get York 50. So that's not an issue. So guys, let me give you a little bit hints over here. Basically, this part specifically contains an error. However, the reason is not like what you just said about you cannot really use the this on the branch name over here, which is not static. That's not a reason, but there's something wrong. I can take one more response from you guys, and I'll give you further hints. If this was wrong, why would that be wrong? We want to know. The hints will be, think about how this particular containing method is going to be called, and then you will see there's some contradiction over there. More hints, if I may. Look at line number 5. I said before, if you actually have a method that's declared as static, that means the method is going to be used the same way as a static variable. How do we use a static variable? You do not need a context objects. You can simply use the class name, for example, bank dot variable name. And similarly, you can also say bank dot method name. What's wrong with that? If you look at line number 5 combined with line number 7, what I highlight in orange, there is some contradiction over there, potentially. Okay, I'll see if there's any more response. If no, I'm going to tell you the answer. Yep, I think along the right track, definitely, but not exactly precise, so I'll help you a little bit. Very good. Okay, let's think in this way. All right, so let's now try to see where the contradiction is. Number one, the fact that you actually got static over here implies you can use the method in this way. You can say bank dot and then get info, right? That's how you call the static method. Number one, okay? And then if we take a look at this one over here, we know that the branch name is actually non-static. That means you must have some context objects to replace this, which we have done a lot in the previous example, right? We can replace this by Jim, can replace this by Jonathan, and etc. In this case, if we are trying to call the method using the class name, do we have some valid context objects in this case to replace this? No, we don't. So what we have is over here, this over here cannot be just replaced by the class name, which is bank in this case. Right? You can see kind of what the issue is. If you're trying to use a non-static variable in the static method, you're going to have such contradiction. And if you try this out in Eclipse, you're going to see some error message like this, which is very confusing. So but I'm trying to explain why there's a contradiction. Non-static method or variable cannot be referenced from the static context. Basically, we say branch name is non-static, but it's being referenced in the static context, which is the static method over here. Right? So there's contradiction. So it's going to be an error. Any questions about this? This one is a little bit tricky, but as a Java programmer that getting to more intermediate level, you should know. All right? Guys, any question about why there's an error here? Everybody's okay? All right, the next question obviously would be, how do we fix it? Let me copy this. Oh, of course, I gotta switch back to iPad. We gotta think about the fix. Okay, let me just go there. And then let me just get it clean. All right. We already understood there would be an error over here. This is where the error is. But now, how do we fix it? There are two possible solutions. Yes, I'll take one from you. That's a very good suggestion. Solution number one, what's your name? Matthew. Thank you, Matthew. Matthew suggested, very valid solution. Since this one being static is actually not good to be used in a static method, why don't we make it static? Why don't we try? If I make the branch name over here static, which means I can simply add static over here. Programmatically, it's going to be fine. Meaning that after you add a static keyword besides the string of the branch name, oh, by the way, S should be capitalized, for the string, just so that you know. After adding the static keyword, everything is going to compile, no error. However, we want to think deeper. Is this solution really making sense? Let me help Matthew a little bit so he can also reflect. Okay, let's say we go with your thought. Let's say if we got static over here, let's now go deeper into what does it really mean when we have a static variable branch name. So Matthew, let me ask you this. What's the difference of non-static versus static? Let's go back to the very definition for such distinction. That's true. Yeah, for sure. For the static variable, you can definitely just use the class name, for sure, know the context object. Let's go a little bit even simpler. Which one is local? Which one is global? Okay. Yeah, absolutely. I'm going to stop pushing you. Okay. Static over here, let's just remember. Non-static branch name versus static branch name. Adding a single keyword is going to make a huge difference. This means the branch name is actually going to be local. This one over here is going to be global. Okay? What do I mean by local? That means each bank, right? Remember, we are in the context of bank. Objects has its own branch. And what about this one being global? That means all the bank objects share the same branch. Share the same branch. And now, can anybody tell me why this one over here, even though it works in terms of Java, but it wouldn't make some real sense? Matthew. Oh, sorry, Marcus.
Whenever you change to create a new object, it's just going to overwrite it so that all your other ones will just follow the same.
Yeah, absolutely. Whenever, well, Marcus just said, whenever you try to call that, actually call that get info method from some object, you're going to change the branch name for sure. But even more fundamentally, does it really make sense for all the banks have the same branch? Maybe one branch in James Street, another one in Leslie Street, but they share the same branch. Doesn't make sense, right? That's a very important point to see. All right, so this one here does not make real sense. So that would not be a good solution, even though it works programmatically. So what we should do is to do just the second solution, right? So this is solution number one, which works programmatically, but you shouldn't really adopt it because it doesn't make sense, right? But you should really see all the details here. And what about solution number two, which I'm going to tell you right away. Solution number two, well, solution number one is about keeping this reference over here by making this static. Solution number two will be the opposite. Since we cannot use it, why don't we just get rid of it? Just get rid of it. And then we got rid of the error. Simple one, but it's because the other solution wouldn't work. Yeah, I'll take a question in just one moment. Solution number two. Yes? Yes, that would be another possibility, yes. Your name? Jasmine. What Jasmine said was you can alternatively also maybe try to get rid of the static variable, so to make the method static. That could be another possibility, which I will encourage you guys to try. Yeah, I'm just suggesting two, but this could be a third one. All right. All right, so we got three possible solutions. At least the first two I talked about. The third one will be left to you as exercise. All right. All right, so that will conclude our discussion on OOP review. Do you guys have any question before I move on to exceptions? Yes. Mm-hmm. Yeah, because this one caused a problem about referring to non-static in the static context. So just get rid of it. So we can get rid of the error. Okay? But the first one, of course, can also do it, but it wouldn't make sense. And the third one, try. All right, if no question here, I would suggest, why don't we pause a little bit and we take attendance, right, to give you guys some credit. All right, just get your device ready. And then I think what I will do, bear with me, I'm going to get ready. Okay, 2030. Start a class. And then the poll, start. And then what I should do, there we go. Okay, this one here. Yeah, I'll pause for 1 minute. Please make sure you can do it now. If you got any trouble, you're going to raise your hand right away. I'm going to have you come over to sign up your name right now. After I ended the poll, I'm not going to deal with any missing cases. Please. You got a problem?
It says we're in the wrong building.
Okay. People have the same issue? Oh. Okay. Thank you. Everybody's okay? Anyone who's not okay so far, please raise your hand right away. Please. iClicker. You're not okay? Okay, you got to do it quick. Okay, we can pause another 30 seconds. Yeah. Yes? Hmm? You're not able to join?
No, I tried to send the answer, but it fell.
You fell. I can send any answer, so it wouldn't allow you to send?
It fell send.
Okay, why don't you just come over? Let's save time. Yeah, can you bring your student card if you don't mind, and then sign up here. That'll be great. Anyone having trouble, bring your student card. Come over here at the front. Okay. Guys, meanwhile, why don't we take a 1 minute break? Don't go away, please. Just stretch your legs, and then we'll get a. Yeah, please. Just put your student number, and then can I just check very quickly? Thank you. You have your student.
I don't have a student card.
Please bring next time.
I need to get one.
Oh, you need to get one. I see. But I recognize you. That's fine. So everyone else is okay, right? Just want to make sure. Meanwhile, I'm going to stop it. All right? I wonder if there's an internet issue, but we can see how that works next time. That's okay. So don't worry about it. Thank you. All right, sorted. Thank you. All right, let's now go back. Okay, let's now start a new topic, which is called exception. All right? And let me now just show you this. I will post the slides shortly after today's class. You can start. I know you got the pressure about lab 1, other things as well, but make sure new content is also very important. I can tell you that exceptions, we should be able to finish that by today. Oh, not today. I need a lecture today, Wednesday, and also maybe a small part of next Monday to finish that. It's not a big topic, but some students, when they gave me feedback, they said this will be the most confusing part of the course. But I'm trying to teach them maybe slightly differently this time. So hopefully that will help. You just need a little bit more visualization of what's going on, but we'll talk about it. All right, so we're going to learn about caller versus callee. This will be the most fundamental model mentally you want to have, caller versus callee. I'm going to visualize that in just a moment, okay? And then when we talk about caller and callee, and then we're also going to get a chain of method call. So that will be for something called a call stack, which I'll show you as well, don't worry. Okay, just want to mention that quickly. And then we're going to talk about error handling. For today, I just want to show you how you would do error handling without exceptions. You would do that in console messages. That is going to turn out to be very error prone, which we have to understand why. And then hopefully next time we can dive more into how you can do it with the exception. And if you want to do exception, that's so-called a catch or specify requirement. That's the number one thing you want to, I'm afraid, memorize. Okay, that's the principle itself. But once you memorize the principle, everything else will go very smoothly. We'll see. And then I'm going to walk through some example with you on Wednesday from scratch. And we're going to see how we can handle with exceptions, and then there will be some more example as well. All right, so that'll be the lecture. Just want to give you some roadmap. All right, let's now talk about caller versus callee. All right. Okay. Very simple definition. Caller is someone who calls others. Callee is someone who gets called by somebody else. Right? Hopefully that kind of makes sense, right? Okay, let's see the more detailed definition. Think about the client is a client using the service provided by another method. I think that's the most intuitive definition I can give to you. Callee is kind of on the other hand, because they provide some service. So we'll say they're the supplier providing the service to another method. So have this kind of intuition in your mind. I think that will help a lot, right? You can get yourself familiar with this definition after today. Let's see how we can visualize caller and callee over here, and then we'll do some exercise together, okay? Let's say we have a class. Let's not worry about public or private. It's not relevant, okay, in this case. Let's say we have a class called C1, and then we have a method inside C1 called M1. Assume that we got another class called C2 elsewhere, and then we create a new object of type C2. And then we called M2, which belongs to C2. All right? I'll give you guys just 30 seconds. Review this part of code yourself. And then make sure you understand what's going on. And then I will actually visualize caller and callee for you. This kind of like a method call within a method is actually very common in any programming language, not just Java. I'm pretty sure in C as well. Right. All right, assuming that you kind of have some familiarity with this, okay. Thinking this way, what we're doing here is in the context of class 1 and also M1. So this will be the calling context. This will be the context of calling M2 from C2. So that's why we said the pair of C1 and M1 is called the caller. Right? It's using some service from some other method. Symmetrically, if you look at, we are basically using the method M2 from C2. So this would be the method being used over here. Okay, so that's why we call it callee. Right? It's the simplest example where you can see caller and callee. All right. Do you guys have any questions so far? Because things will get more complicated later, but I want to make sure the simplest scenario you can understand, caller and callee. Get yourself familiar with caller and callee at least before Wednesday. So when I refer to them, you will feel comfortable. Any question? Yes?
So the caller is calling
Mm-hmm.
which is M2.
Exactly. Caller is calling the callee, and callee is being called by the caller. Yeah, if that makes sense. Right? Yes, all right? Quick exercise for you guys to think about, right? Can a method, for example, M1 or M2 in this case, can they be a caller and a callee at the same time? Can they? Okay, you guys can agree? I agree too. Why don't we try to visualize how that's going to happen? For example, let's say case number 1. In the case of C1 M1, currently is the caller. How can it be callee at the same time? Can anybody sketch? And then I'll put it down. How can the caller C1 M1 be a callee at the same time? How is that possible? What would you have to show? Jasmine.
You have to show that you have to create a method, maybe 2 methods, and then the second method call the first.
Yes, basically, yep, I agree. So why don't we try that, okay? So we can try, for example, we got another class, let's call it class C3, okay? And then possibly we got another method, I'll just make a mutator, doesn't matter. And 3 over here. And then inside, we're gonna create, let's say C1 object would be new C1. And then we're trying to use it, O.M1. Now you can see that C1 being the caller can also be the callee at the same time. All right, that's example number 1. Similarly, the callee in this case, can it be a caller? Can it be? Should be in a similar way, right? So that means in the definition of M2, if you simply add maybe some method called inside M2, well, that's a caller, right? I'm going to write it down. Number 2, you can assume, for example, let's say we got class C2, and over here we got M2, let's say. So we got method M2, and now let's make it a caller. We can say C3, for example, and then new C3, and then O.M3. You can easily see that in this context, C2M2 is the callee, but now in this context, C2M2 is the caller, right? So definitely, caller, callee, they might just exist, coexist on the same class and method pair. All right, this is very fundamental. That's why I want to spend enough time with you. Really important to get it right. All right? Let me see if I missed anything from the slides. I think we're good. Okay. Now, stack of method calls. For those of you who might be a little bit ahead of everybody else, you might have heard about a word called stack. This is a fundamental data structure that will be studied in more detail in EECS2030, maybe for many of you in the winter. But I think for the purpose of this course, I'll just need to give you just how to use it. You'll be quite intuitive, right? Well, we'll see how that goes. The best way to understand what a stack is by using an example, all right? I want you to stare at these 3 boxes. And for simplicity, I just used the different color, blue, green, and orange to say they are in different classes, all right? So we got M1, we got M2, we got M3. Now I want you to take a look at very quickly about somehow the Callee relationship between them. Take a quick look. Okay? Stare at that for 30 seconds. It should be rather easy. Okay? Okay, so informally speaking, if the execution flow of your program somehow goes to M1, we're going to execute this line here first, and then when we get to this line over here, we're actually going to execute M2. At this point, the rest of this M1 over here is going to be paused until we finish the execution of M2. All right? So how do we execute M2? We're going to go to M2 over here, and then we're going to execute it line by line. When we get to this line over here, we're going to execute M3. Until it terminates, the rest is going to be paused. Not terminated, just paused. How do we execute M3? Similarly, we're going to execute line by line. Let's say we are done with M3. That means we're going to go back over here. M3 is done, so we can continue with the rest. Once we are done with the last line of M2, we're done with M2. We're going to go back to this point over here, and then we're going to go on to execute the rest of M1. That's actually what's going to happen in the runtime. All right, that's the first goal, right? It's gone. All right, I'm going to use a stack to show you how you can trace it using a stack. There is a notion about first in, last out for the stack, which you will get more exposure in 2011. But for now, I'm just going to write it out. Okay? Last in, first out. That should be the right word. Last in, first out in the sense that the last method I'll put into the stack, they're going to come out the first. But let's see how, right? Let me just do it again. Okay? Let's say we now want to execute this method in 1. We'll start with this. Execute line number 1. Okay? And then, you know what? Let me just number them just to be more precise. We're going to execute M1. So the first line we execute will be this line over here, number 1. And then number 2. Before we can terminate number 2, the rest over here will just be paused. Okay? What happens so far is like this. We start with M1. So we're going to put M1 onto the stack. And then finish this. And when we execute this, now we want to execute M2. So that means we put M2 on top of the stack. And then while we're executing M2, we're going to execute line by line. So that will be number 3, number 4 over here. When we get to number 5 over here, we have to execute M3. Before it terminates, everything else will be paused. So that will be M3. So we go to M3 over here, and then we're going to execute line by line. Number 6, number 7, number 8, number 9, number 10. After we have executed number 10, that means we are done with M3. What we'll do is we're going to go back to where we were over here. M3 is done. That means we're going to remove M3 from the stack. Right? It's done. And we're going to continue with the rest. So that should be 11 and then 12. After executing 12, that means we are done with M2. Remove it from the stack. That will correspond to, so if we go back over here, M2 is done. And we're going to continue. That'll be 13, 14, and 15. Once we're done with it, we're going to remove N1 as well. And the stack becomes empty again. So you can think about, in your Java context, what will be the first method to be put into the stack? The main method. All right? And then you will stack on top as many methods as we need. And then ultimately, once everything's finished, the main method will be removed from the stack. We got an empty stack, and then we're done. Guys, it's a very important execution sequence you want to understand. If there's anything not clear, now it will be the time to ask. I'm pretty sure I'll ask you something about this in written test number 2. Not tomorrow, so don't panic. You have time to learn and ask me questions. Yeah. I can pause for 1 minute. You guys can think about it. If there's any part not clear to you, just ask. All right? Yes?
Is this not like a temporary memory?
Yes, you can think of it. Yes, it's like a temporary memory. Yeah, you can think about that. That one is actually going to be managed by just the runtime system, which you don't have to worry about. We're going to see the stack in 2 occasions in this course. The first one will be how we trace the method call, like a chain of method call. The second occasion when we talk about recursion, which will be the final part of the course. Yeah. But when we get to 2011, give you a little bit look ahead, we're going to see how useful stack would be. Simple data structure, last in, first out. Oh, by the way, why last in, first out? You can see this will be the first method put into the stack, but it's last out, the last one to be removed. On the other hand, M3 was the last one that's put into the stack, but it was executed first, right? So that's first out. All right, I presume everybody's okay, but don't worry. Recording's there, notes is there, study that, and struggle a bit, and then learn it, right? Okay, we're going to do at least 2 examples to see how we can build this stack. Just more concrete example. I think it's so important. Okay, let me see. Okay, that's fine. All right, so stack of method call. You guys can take a look. That will be exactly what I said. So the example I'm showing over here is something I'm going to talk about, the bank example. I got 2 examples for you. One is about circle, the other one is about bank. But the one I just put over here is just more symbolic. Okay, let's try. All right, we'll talk about caller Callee. We'll talk about call stack. And let's now talk about how we can do error reporting. I'm going to use 2 simple examples to show to you why it would be quite bad if you only try to print out some error message to the console without using the exception. That'll be the main point we want to get by the end of today. Right, let's take a look at some Java code quickly. Right? Let's say we have a circle class and we got double radius, the attributes. Again, don't worry about private, public, right? They are kind of not relevant to the discussion here. We have a constructor circle over here, which will just set a radius to something, maybe 0, let's say by default. And we got set radius over here, which will give you some radius. And of course, potentially, we cannot control the caller of this method, right? So the set radius being the callee can take any arbitrary integer value, including any double value, including negative, in which case we must report some error. How do we report the error? The ideal way, as we'll learn, will be exceptions. But for now, let's live with what we know already. System out of print line. It might just be good enough. Okay? If R is negative, we're going to report some error, just to say invalid radius. Otherwise, we'll set the radius of the circle to be R. Very straightforward. Right? Seems to be reasonable error handling mechanism. Seems to be. And then we also got the get area accessor, which will return radius times 3.14 pi. All right? Everything compile. You may not, I will let you stare at this for 1 minute. I can tell you that there is some fundamental flaw in the program, especially when you try to use it. I'll give you 1 hint. When we do error reporting in line number 5, that means if the user passed a radius that's negative, of course we want to really give the error back to the caller. At the same time, the caller shouldn't be allowed to continue with their code because they gave you something that's wrong. That's really the key to think about. Okay? at least think about what I just said, right? Think about how the program is going to be run, and then we're going to see why this is not good enough. And I'll show you on Eclipse as well. You can also try. Okay, let's now take a look. I'll give you more context over here. If you take a look, so the circle class we just went over, all right? Let's say we got another class, which will be the caller of the set radius, all right? In this circle calculator, we have a main method, all right? So circle calculator and main will be the caller, right? So you can also see the way I color the text will also indicate. Circle calculator and the main, that will be the caller. On the other hand, we are trying to use the circle set radius method. That one will be the callee. All right? And let's see how we use it. We say define the circle objects, and then see that set radius, we give some invalid input, -10. Should not be allowed. And when we execute, when we execute this line over here, okay, -10, that one there is going to actually replace this to be -10, meaning that we're going to satisfy this Boolean condition. We should really print out invalid radius. Up to this point, it's okay. But the caller here is trying to proceed with the computation over here to go ahead, calculate the area, and so print out the area. If it was a good error handling mechanism, once we have found error in this case, the rest of the program should not be allowed to proceed unless you somehow handle that. All right? Let me put it down, and then using the judgment, we can see. For error handling to be acceptable, these lines should not be allowed to continue. Should not be allowed to continue because we got some invalid input, -10. All right? But in this case, are we allowed to continue to line number 5 and 6? Indeed, because it's only a print line, right? You can see this part over here is only just a print line. This part over here will just print error, but would not stop the execution of line number 5 and number 6 over here. Of line 5 and line number 6 here. Right? That would be very important to observe, and I'll show you right away what I really meant. All right? Let me show you quickly on Eclipse, which will be quite important to see. The source code, I'm also going to make available to you. Bear with me. And then we're going to look at the caller, callee, and call stack in just a moment. Yeah, sorry, I should have launched the Eclipse. I'll do that next time. All right, let's launch it, and I'll show you how you can find this class to do the experiment yourself. Okay, should be there soon. All right, there we go. So you're going to see a starter project today. It's called Exception, Circle, and Bank. All right, under which you will see under the source there are several packages. You want to look at, for example, the circle without exceptions. That's what we're talking about right now. All right. If you go inside, you got the circle class, which we just went over. All right, take some time to load. This one, right? And also the circle calculator, we also went over, right? Like that, right? Okay, let's try this. If I execute the circle calculator right away, enter radius. If I say 23 is a normal input, that's okay, right? On the other hand, if I try the following, let's say -10, you can see it gave an error on the console, but still proceed with the calculation. That's fundamentally wrong. If an error already occurred, you shouldn't really go ahead and proceed with the circle calculation. That's what's wrong. Let's understand that, all right? Understanding this, but we're going to see later, the ideal solution is by using exception, meaning that once we reach this line later, as soon as we reach this line, we're going to throw an exception. That's what we call. We'll give more detail next time. Once we throw the exception, these two lines will just be disrupted. You can never get there directly. All right? And one final thing about this example here. How do we build a call stack over here? Since we are trying to execute the class over here, circle calculator and also the main, right? So this will be the starting point. So we're going to say circle calculator. I'll just say CC, circle calculator dot main. That's the starting point. And then while we're executing this one, this method here, we'll reach circle and set radius into this class, all right? So that'll be the Callee. So that means we're going to get into circle and then set radius. So that'll be the call stack that's going to be built. Of course, this part is going to finish execution over here, and after that, you can do the remaining part for cc.main, right? That's a call stack. Yes? You mean for, oh, sorry, say it again. You mean the online? Oh, okay. Line number 5 over here, it's a good question here. The question was, can we just use system.error.print line? For that one there, I'm not too sure what's going to really happen. I can try and then get back to everybody. I suspect after this, you will still get a chance maybe to get to the next two lines. Even if you wouldn't get to them, it's still not a good solution because somehow you're only printing some message to the console. But I cannot really have a way to grab the message from the console and do something about it. Do you exit the whole program? You mean just exit over here? Yeah, sure. It's still going to be fine. Okay. If I say maybe exit, for example, there's a way to do it. However, when you exit, you don't really give the caller over here to have a chance to do something about it. Maybe you want to allow them to say, you give me -10, I'll give you a second chance to really enter maybe another number. Exit over here, I'll put it here, can disrupt. Line number 5 and 6 to continue. But it would not allow the caller, which would be circle calculator main, to handle, because you just exit from the program right away. You wouldn't give them a chance to handle the error. For example, you wouldn't allow them to enter another number. Yeah, I would say this part here could be slightly advanced because we don't necessarily have used an exit before in the Java course. But I think that will work only to some extent. Wouldn't work completely. Yeah. Yeah. You can try maybe some complicated code, to actually maybe do some error handling. But I would say you're making this method here unnecessarily complicated. We want to make it as simple as possible, just if and else. But just by adding another dimension, which will be exception, that can just make everything work, rather than having complicated even the loop. Right? Yeah. It might work programmatically, but since we are now in Java, we should really try to use exceptions or OOP. Yeah. Yes. Okay, sure, that's a good question. The question was, let's say, rather than entering just negative number, what if they enter a string? I think that'll be another issue, for sure. Let's try. Why don't we try? I think it's going to crash. 23, all right? All right, it's going to be some kind of like exception, which Java will do, okay? But it's crashed because you're expecting maybe some number, but you enter some string. It's another category of error. So Let's not go there. All right. Any more questions about this? We okay? Okay. And let me now try to go over another example. That example is simply just involve more classes. Okay, let's now take a look. You guys can take a look here, and then we'll only get to programming exception more on Wednesday. I can do it from scratch, but for today, just understand what the non-ideal solution would look like. All right, everything has been discussed. Okay, about a bank. Okay, why don't I just go directly to this part over here? Okay, let me just switch. There we go. Let's take a look one by one. Let's start with the account class over here. In the account class, we got ID, we got balance. Okay, we got a constructor which will initialize the ID. Of course, you can feel free to make it more automatic by using static. You can do that. Okay. Also, we got deposit, and also we got withdraw. Apparently, you should not be able to deposit like a minus. You should not be able to withdraw like a minus a million, right? So that's why it should be an error. So we got error condition here. We got error condition here, and then otherwise, if there's no error, we're gonna either increase the balance or decrease the balance. All right. Stare at the account class for a moment. Just make sure you're okay with it before we add the second class. We got 3 classes to understand the caller callee. Okay, just make sure you understand the first one. Account. Yep, with the balance and also with the deposit and withdrawal. Things should be quite conceivable, quite reasonable. Okay? Let's look at the next level. Let's say we have a bank class over here. And this will be using our programming pattern. So the bank simply got an array of accounts. And we also got a counter to help us, right? We got a bank, which we can give some ID. And we're looking at this particular method called a withdraw from. Because now if I want to withdraw, for example, $5, I need to know which account do I want to withdraw the $5 from, right? Because we got so many clients, or so many accounts in the bank. So what we should do, well, this might give you some inspiration for lab 1, actually, right? You got an array of the accounts. You want to find out exactly that one account with that particular ID and do some withdrawal, all right? You got for loop, and we'll simply go from 0 until number of accounts. And then we say if the current account we are looking at, the ID will be equal to ID, that will be the account to withdraw from. And then we're going to call accounts I, which will be that particular account that withdraw. And this withdrawal method is referring to the withdrawal method right here. All right? I will pause just for one moment for you to digest just the second class. And then we introduce another one. Realistically, you shouldn't be too surprised. Sometimes for your project, you will involve so many classes in the call chain. But for the class, let's do something simple first. All right, just digest the bank and account. Don't worry bank application just yet. Any questions so far? Good? All right, let's now take a look at bank application. That'll be the final class for us to look at, okay? That should be good enough, okay? So we got bank application over here, and we're using the main method. Usually, once you get to the main method, it's really the final level. That's the application level. So we're gonna read some input, we're gonna output something, right? But let's see what we do. We create a bank object here, and then we create some account, and then we try to add the account into the bank. So there's only one single account in the bank. And then we're gonna read some input from the bank application user, some input for the withdrawal. Of course, we want to make sure if they say, I want to withdraw minus a million, there should be some error. Not only there should be an error, the execution should really stop right away without continuing, right? Similar idea. If you got a negative radius, you should really stop the calculation right away. So we're gonna call b.withdraw from, all right? Now, can anybody without looking, where is this class that defines the withdraw from? Is it account or bank? Bank, right? By the way, you don't really need to look back. Easy way to tell. B here is a context object. What's the type of B? Bank. So that's got to be from bank. All right? Right, that's something you should really feel comfortable, right? That's part of the review. All right, and then once we withdraw that, and then we might say transaction completed. All right, so that's the 3 classes we got. Do you guys have any questions so far? All right. Before I try to build a call stack together with you, I would suggest we try to run it. If you go back to the same project, right, there will be another package. It's called accounts without exception. And then we got, let me just close the previous classes just to avoid confusion. So we got account, we got bank, and also we got bank application. Okay? And let me just run the code right away. How much to withdraw from the only account with ID 23? If I say 100, that's a valid input. Good. Withdraw after withdrawing 100. Well, I can tell you that this is already not so good because the only account, 23 over here, the initial balance is actually 0. How can you withdraw 100, right? Let me do a better example. Let me show you once more. How about this one here? How much to withdraw? Let's say initially the balance is simply 0. If I say 0 over here, nothing, right? But what if I try the error case? If I say withdraw minus 100, that one should not be allowed for sure. We do have an error over here to say invalid transaction, like an error for the negative radius. However, not only that, we still allowed the withdraw method to really continue, the rest of the caller code to still continue. That's what's wrong. After the error has occurred, we should break the execution flow right away without allowing anything else to be executed. That's something we want to keep in mind, right? So this really shows the inherent disadvantage of using console messages. You wouldn't break the execution flow right away. That's something we'll see for exception. That's why things will get a little bit trickier once we see the exception, right? Several things I want to do, okay? Number one, let's try to understand the caller-callee relationship a little bit better, all right? The demo I just did, basically we started with the main method over here. That's the starting point, right? I'll start with this, and then you guys tell me how I can finish the rest. So we start with this class, so that'll be bank application. Bank application, and also the main method, right? So this will be the first caller we have. So the context will be the bank application. I'll say BA, all right? The caller, it will be this particular main method. And what will be the callee in this case? I'll make it larger. Inside this, the context of this particular class, this particular method, what will be the callee? Bank? Yeah. Well, it's quite obvious. Bank, and also withdraw from. Agree? All right? So for the callee, I'm going to say bank, and then withdraw from. At the same time, I can also put onto the stack. We start with the bank dot main. This will be the starting point. All right? And that means we should move to the context of here, right? So whatever that's being called is now going to become the context where we're going to talk about another caller-callee relationship. So now we switch the context to bank.withdraw from, which is over here. All right? Let me just use a different color here to show to you. So now we switch to bank withdraw from. All right? So what I would do is I'm going to say bank. The caller will be withdraw from method. Okay, let's make it a little bit bigger. Now, what about the callee? Account that withdraw, I agree. Can you tell us more specifically? Okay. From which line? Well, it's obviously, we can tell from this line, we're calling the withdraw method over here, right? It's more important to understand. This will be the method for the callee. What about the class of the callee? How did you tell? It should be account.
The accounts that like from the line above it, the accounts and the account array, not like
Exactly. So guys, what I asked is a follow-up to your classmate. That's a very important follow-up, all right? Let me just say it again. Here you can see we're calling the withdraw method. That one's all good. However, what about the class? You should really look at the context objects. This will be the context object, which is accounts at index I. And as you said, we actually declare over here accounts will be an array of accounts, meaning that every element there should be of type account. So that's how we figure this should be account. I'm pretty sure that's what you meant. Awesome. Good. All right. So what I'm going to do is here, it should be the callee should be withdraw from the account. So it should be account dot withdraw. And on the call stack over here, I'm going to show you one more thing on the Eclipse as well. Okay, account, and then withdraw. Okay, finally, we switch the context back to account class over here. And since we're calling withdraw, we have to withdraw over here. That'll be the last context. It would be account, and then the caller would be just withdraw. And the final question, if you look at this method over here, is there any callee in this case? No, which is okay. All right? You can see there's simply no further method call, so not applicable. That's what I will put. All right, so let me just put it down over here. And then we also got a kind of, yeah, that's good. I think I made some typo over here, which I'm going to fix right away. Okay, I think this part here is not exactly right. Account of withdrawal will be the last one. But before that, let me fix that. Otherwise, you might just get confused in the notes. The first one should be the green one. That should be bank application. Bank application.main. The middle one should be bank.withdraw from. Right, so these are the three. Right, so you can see both this table here and this call stack. I think they will both help you understand what's really going on over here. All right. Any question until now? So what we have learned so far: caller callee, call stack, why it is bad to have console messages for every reporting, and also, given the code, how you can build the call stack and the table like that from scratch. Right? All right. One more thing I would like to show to you, which will be very practical for you to also try. Okay, so if I go to Eclipse, let's try the bank example. All right. We know that if you want to execute this particular project here, this package here, you must execute a bank application. You want to say right-click and say run as Java application, because you got a main method over here, right? What I will do now is I want to show you how to visualize the call chain in Eclipse. I'm going to use debugger, and I'm going to execute line by line. Right-click, debug as Java application, all right? And let me just enter 23. But actually, I want to step over line by line. Let me switch to debug perspective over here. And then I want to make sure, once I read the input, I'll pause over here. All right? So let me say I want to withdraw. Why don't I say 10, just for now? Oh, you know what? Let me do it again. I didn't really do it quite properly. Let's say I still put a breakpoint here, and then I'm going to say right-click, debug as Java application. Okay, I'll switch to debug. Okay, now I'm here. Okay, good. I'm going to enter, let's say I want to withdraw, let's say $10, just for now. All right, good. All right, so now I'm going to execute line by line. So let's say I say step over here, and step over. So far is okay. Step over, step over, step over. And how much to withdraw? Let's say I want to withdraw $10. And then I'm going to step over here. Okay, so this would be the withdraw from. That will be a starting point. How do you see? If you remember, let me remind you. As soon as we try to make this particular method call, let's say we don't want to step over. We want to step into the execution of withdraw from. How do we do that? Right? We want to see how we can go from this into this and then into that. That's something I want to show to you. All right? What we can do is like this. Go back to the Eclipse, right? At this point, rather than saying stepping over, I'm going to say step into. As soon as I step into, I'm going to step into the execution of this particular method. The context object B, which was declared as bank, right? I'm going to switch to that particular context. Let's try that. If I say step into, you can see now I'm in the context of the bank, right? And we are now here, bank. And then when we get to this particular line, I'm going to say step into once more. In that case, I will be able to get to the withdraw method. I want to show that complete tracing to you, so you can also try yourself. It's going to help you maybe in the future. Let's do that quickly. Okay, we are now in the bank class, right? Let's try to step over. Yeah, at this point here, you can see we now got the accounts I. We know that it's going to be account. So if I say step into, we can expect to switch the context once more from bank into account. If I say step into, you can see we're now in account. Agree? Okay. If we are now in the account, and now we're going to execute whatever it is. And one more thing. What's going to happen? Let's say I step over to finish executing the withdrawal. What's going to happen? According to the diagram, I'm here executing the entire method here. We know that that will correspond to finishing this particular method, right? Removing that from the stack, and then we'll go back to the context of bank that withdraw from. Guys, remember that kind of sequence over there? Let me repeat once more, okay? We are now at the top of the stack, which will be to execute this method here. As soon as we finish executing this method here, according to what we said before, we're going to remove this method because it's done from the stack. And then, once this is done, we're going to switch the context back to the next one in the stack. That one will be bank that withdraw from. All right? Just make sure you actually understand what's going on here. Let's try that. If I try step over, we now will switch back to the context of bank right away. And if you only look at the Eclipse, that could be slightly confusing. But if you have that mental visualization, once more, final time. When we were here, this is how the call stack looks like. We got 3 calls in a chain. Once we finish this one here, we're going to finish this. So that means we return back to the context over here. So this could be a written test 2 question, something like this. I can say, let's say we are now put a breakpoint exactly over here. And then what's going to be the context? After finishing the final line in this method, where should we switch to? We should switch to this one here, right? Because we finished this, we should really switch to here. All right? That's for written test number 2, don't worry, not tomorrow. But that's something you should struggle a bit and then get clarified. Okay. And I think that's about the error reporting for the bank. And then what I will do is, we have a choice. I think I got about maybe 9 minutes or so. You got 3 choices. Number 1, I can cover exceptions at a very conceptual level by reading off the slides. And then we'll do the programming on Wednesday. Choice number 1. Choice number 2, I'll let you go now. Choice number 3, I can talk through maybe 2 of the example questions on the written test 1. I mean the practice test, written test 1. Do you guys have any preference? 3? Okay, you guys are smart. Awesome. Why don't we do that? I knew you're going to choose that. Good. But I would suggest before Wednesday, optional, if you just want to take a look at the slides over here, lots of words, look at only these 2 slides. These 2 slides wouldn't make so much sense now, but at least go over them, have some idea. And then once we go over the programming example on Wednesday, it will make more sense. All right? Let's now do some walkthrough for your benefits. Okay, why don't we start with this one here? Everybody tried this one already? I hope, at least some of you, okay? If you haven't tried, why don't you stare at that for 1 minute for everybody, okay? And then I'm going to solve it right away. My plan is to maybe do 2, but we'll see. At least we can do 1. This one is slightly more complicated than the other one. All right? And you should really find this quite familiar, right? Isn't that some example we did in class, right? Okay, I'll pause for another 30 seconds, and then we'll do it together. Okay, let's try. And just don't forget, tomorrow you can bring a piece of paper for sketching. I think you need it. All right, let's try. Let's try to do the person objects creations over here. All right, we got P0, P1, P2, P3, right? P0, I think we only need just the name. Okay, I think we should be okay. We just assume just the name. P0 will be a person object here. I'll just say P. It has the name. Okay, I'll put the name in just a moment. P1, also person with some name. P2, also a person object with some name. And also P3, different object. We got 4 different keywords for the new. All right, let's put it down. First one, Suyang. Second one, Yuna. Third one, Sanhei. And the final one, Jihei. Any doubts so far? At least you can do that, right? Okay, let's try. Now we got to do some redirecting. This one here, P0 is assigned to P2. We're copying the address from P2 into P0, meaning that diagrammatically, P0 rather than pointing to here is going to point to wherever P2 is pointing to. Agree? Okay. P1 is assigned to P3. Similarly, P1 rather than pointing to here is going to point to wherever P3 is pointing to. All right? Hopefully so far so good. And then we're going to do something very similar to what we did before. Here, let's do these 2. Right? What about the first one? This one here, we're creating persons 1 array with index 0 storing this, index 1, index 2, index 3. Right? Excuse me. So what we got is we got persons 1 array. You know what? Let me use a slightly darker blue. Persons 1 array is pointing to an array of size 4. 0, 1, 2, 3. Right? Index 0 should be pointing to P0. And notice that P0 is now here, right? And then index 1 should be pointing to P1. P1 is actually here, right? P1. P2 is actually index 2. Index 2 should be P2. Index 2 should be P2. All right? And also index 3 should be P3. All right? Like that. All right? Nobody's lost, right? I hope. Awesome. You guys are good. All right, let's now try. Persons 2, that one there is going to be, at least we can finish this one. Okay. Persons 2 is just going to be another array of the same length as persons 1. 0, 1, 2, and 3. All right, we're going to run this loop over here. And it's going to be bounded by persons 2, that length, which is 4, right? 1, 2, 3, 4. So I is going to start with 0, so 0, 1, 2, 3. 4 iterations. Agree? Okay. Let's try this. In the first iteration, I will be 0. Right? What about this expression over here? Persons 2, that length is always 4. 1, 2, 3, 4. 4 minus 0 minus 1 will be 3. And second iteration, 1. 4 minus 1 will be 2. Third iteration, 4 minus 2 minus 1 will be 1. And fourth iteration, 4 minus 3 minus 1 will be 0. All right? So now we have some interesting redirection to do. Okay? Let's try. So what we are saying is, the first one, persons 2 at index 0, reassigned to persons 1 at index 3. Let's try that one. All right? Persons 2, 0. Rather than pointing to null, it's now going to point to persons 1, 3. Persons 1, 3 is pointing to here, right? So that means persons 2, 0 is going to point to that array. Second iteration, persons 2, 1 over here is going to point to persons 1, 2. Persons 1, 2, let me use a different color if I may. Let's try that. That one there. Right? So persons 1, 2. Persons 1, 2 is actually pointing to this object over here, right? So that means we have something like this. Okay, let's finish the next 2 iterations for completeness quickly. Persons 2, 2 over here. Persons 1, 1. Persons 1, 1 is actually pointing to this object here, right? So that means we also get this. Finally, final iteration. So we got 3, persons 2, 3, persons 1, 0. Persons 1, 0 is pointing to here, right? So that means we got possibly something like this. All right? Of course, if you do on paper, just make sure you can do this rather quickly. All right? So after this, we can now answer the question. For example, let's say the first one. If you got persons 2, 0 that get name, persons 2, index 0 is pointing to this particular object over here, right? What will be the name? Jihei, right? That one just for example. And for the rest, you can simply just look at the diagram, get the answer. Are you guys feeling comfortable about this? Okay. And I'm pretty sure you wouldn't mind if I take 1 more minute. Let me stop the recording.